Hey guys, this looks like a fun one. It says, what's the angle? We want to know this angle right here. So let's make this thing black. So now you can see there's two circles and the angle. I think it's safe to assume that this is tangent here, here, and here. If you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. So let's copy this down here. These two circles are tangent right here. So let's construct the tangent line between the two circles. And then I'm also assuming this is tangent right here, so let's draw this tangent line. There's a special property if you have two tangents to a circle. If the tangents intersect, these two distances are the same. So if we go up here, let's shorten this tangent line and shorten this tangent line. And then since these are both tangent lines to the same circle, they're the same length. And then if we take this line and make it all red, we now have a nice looking red triangle, and it's an isosceles triangle. Since these two sides are congruent, that means these two base angles are congruent. Let's call them both A degrees. Let's clean this up and let's give ourselves some room because we're going to look at this other tangent line and we're going to extend it all the way up here. This red distance and this red distance will also be equal to each other. And if we complete this right here, we have another cool looking red triangle that's also isosceles. Since these two sides are congruent, the base angles are congruent. Let's give them both a measure of B degrees. And now let's clean this up. And then this angle right here is made up of B and A. We can make it a single angle of B plus A degrees. And this B plus A degrees, that is our question mark. So we can say question mark is equal to B plus A degrees. This looks important. Let's put a box around it. And let's move it down here. Next, let's focus on this quadrilateral right here. This angle will be a right angle because of the rectangle. And let's focus on our new quadrilateral. The sum of the interior angles of any quadrilateral is 360 degrees. So we can say 90 plus A plus A plus B plus B equals 360. Then let's subtract 90 from both sides. On the left-hand side, these are gone. A plus A is 2A. B plus B is 2B. And then on the right-hand side, 360 minus 90 is 270. Then we can divide both sides by 2. On the left-hand side, this is A plus B. And on the right-hand side, 270 divided by 2 is 135. So now we know A plus B is equal to 135. And our question mark was B plus A. We can switch these. And now in the place of B plus A, we can plug in 135. So this is the answer to our question. This angle is going to be 135 degrees. Let's put a box around it. How exciting. This is the answer to day 11. This is the puzzle for day 12. It says, what's the area of the semicircle inside this equilateral triangle? So we're given that this circle's 6. We're given that's an equilateral triangle. That's super helpful. And then we're given this semicircle. This will be a fun one. How exciting.